So the topic today is rhythm, and what we need to start with, of course, is a good definition of what rhythm is. Prior to this, we've been talking about pitch. When we talk about rhythm, we're talking about the time aspect of music. So rhythm is the duration of pitches, accents, or silences. Okay? So rhythm, we're dealing with duration. And it can be of multiple things, because we can have rhythm without pitch. We can have rhythm with pitch. And the length of silence is just as important as the length of sound that we're dealing with. So that's what we're talking about when we talk about rhythm. Specifically, when we talk about a beat, we have to be specific. We're not going to use the more general term of like, oh, that's a good, that hip hop album has some great beats on it. We're not going to use it in the general. We're going to use it in the very, very specific. The beat is your steady pulse. So, beat. The key part is that it's steady, reoccurring pulse. Okay, steady, reoccurring pulse. So when I say clap the beat, if you do anything that goes like, I'll be like, that is not the beat. That is a rhythm that has a variety of durations in it. A beat must be steady, like hopefully your heart. If your heart functions like a rhythm, we're going to rush you to the hospital. Right? So we want a steady, reoccurring pulse. Now, once we have that steady, reoccurring pulse, we can talk about tempo. Tempo is the relative speed of that beat. So we can have a fast beat, slow beat, anything in between. So it's important that we have this common terminology so that we know exactly what we're talking about. With this as our framework, we're going to talk about the durational symbols that are used. In other words, the note values and the rests that correspond with those note values. Keep in mind that this was something that hasn't been around forever. Evolution of music. This is something that was invented in the 14th century, and we're still using it today. And that's how you can use measured notation. So note values. A circle with nothing filled in, a white note head. So we're going to read that as called a whole note. We don't know how many beats it gets. That can be varied. Right now we just want to know the names of our note values. The symbol for that whole note is a box, a rectangular box that hangs down from the third line. So, maybe not, third line. Yeah, third line. So one of the ways that I think is a good way to remember the difference between a whole and a half rest is that with the whole note, if you have a little guy, I'm going to make my little stick figure, and he's walking along this line, he'd fall into this hole. Whole note. Whole rest is this in this case. Whereas this here, where you have this, I'm going to draw a little head, a smiley face. He's wearing a hat. Hat starts with H, just like the word half. So whole note and half note. A silly way to remember. Okay? So I'll leave that up there. So the next is a half note or a half rest. it doesn't matter which direction this stem goes. A circle is called the note head. The line is called the stem. You'll notice that the stem is, when it's attached to the left side of the note head, it always goes down. When it's attached to the right side, it goes up. So that's something to remember. So we have either, I'll write it over here, that or that. When the stem is attached to the right side of the note head, it goes up. To the left side, it goes down. Whole note, half note is exactly half of that. So however long our whole note is, how many beats, because that is our measure, that's how we measure time in music. We don't use seconds, we use beats. So how many beats does a whole note get? It depends. And that's going to change. So we'll talk about that in a minute. But all of this, this all goes back to ancient Greece and why mathematicians loved music. One of the reasons mathematicians loved music is that it's all about numbers and relationships. So half of a half note is a quarter note. A quarter note would be a black note head with a stem. Now we'll write that a little clearer. And the rest would look something like a lightning bolt. And that would be your quarter rest. Half of that would be an eighth note. Eighth rest looks kind of like a 7. Eighth note. Black note head, stem. This little line like this, that is called a flag. Flags always go to the right. And it doesn't matter if we have the stem going up or the stem going down. You'll notice that the flag is attached and goes to the right side of the stem. Some of you may be thinking, why do I need to know this, Dr. Brellochs? Sibelius, finale, muse score, it just does it automatically. That's wonderful, but what if one day you're in a rehearsal and you need to write something out by hand? You should know what the notational methodologies are, okay? So after that, we have a 16th note, which is the 8th rest with another extra line, or with 2 flags. One thing that happens that you should also know is that for both 8th notes and 16th notes, we can group them together and substitute a beam for a flag. So if I had 2 8th notes, I could write it like that with 2 flags, or I could take away the flags and put a beam, which is a horizontal line that connects them. Same can be done with 16th notes. You take away the 2 flags and substitute it, let's say, with 2 beams. So that would be called beaming 16th notes, beaming 8th notes. So these are the most common note values and rests that we have. And what happens is we measure them in terms of beats. So for example, if I tell you that a whole note equals 1 beat, using your powers of math, a half note would be half of a beat, and a quarter note would be a quarter of a beat, and an 8th note would be an 1/8 of a beat, and a 16th note would be a 1/16 of a beat. Now, in music today, whole notes usually aren't 1 beat long. Most commonly, they're 4 beats long. So, if a whole note equals 4 beats, we then just use our powers of math again, and a half note would be half of 4, which is 2. A quarter note would be a half of that. Each step is a half. You keep going, like divide by 2. Would be 1 beat. An eighth note would be a half of a beat. And a 16th note would be a fourth of a beat. And one thing to do and keep in mind is to not only intellectually understand that, but be able to demonstrate that. So if you were to be asked to say, clap a beat, you would clap your hands like so. And if I were to say, why don't you sing for me a whole note? You would do something like this. You would hold one sound for 4 claps, because the claps are representing the beat. And if I were to ask you to sing whole notes one after another, it would sound like da, da, da. And then I say, okay, half notes. Now again, this is only half notes if this. So really I'm saying sing a note value that lasts 2 beats. We're going to call it a half note. It would go da, 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 da. Quarter note, you kind of, whenever I do quarter notes, I feel like a seal. Do, 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 right? You clap your hands and you say something. When you get to eighth notes, that's half of a beat. So, again, using our mathematical knowledge, how many eighth notes go into 1 beat? A half plus a half equals 1. 2 eighth notes into a beat. So if you were to have to demonstrate by clapping, like I was just singing these other note values, you would do something like dot 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 1 2 1 2 1 2 1 2. And if you were going to do 16th notes, you would need 4 of them. 1 2 3 4 1 2 3 4 1 2 3 4 da 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 da. And that's how you would do those note values. Everything changes depending on what equals one beat. So if I erase all of this, and I say, no longer does the whole note equal 4. Now the whole note equals 2. Every note value now changes. And this is probably reasonably easy for you all to follow along and say, intellectually, I understand that. But when you have to actually read music with different time signatures, where the beat gets different note values, you have to have your eyes adjust and rethink, oh, so when I'm tapping my foot with the beat, this is what that equals. So sometimes it's good for us to take a step back like we're doing right now and really be clear on what it is we're talking about. So that'll help you do that when you're reading music in unusual time signatures. So if the whole note equals 2 beats, that means 1, that's a half. Eighth note is a quarter of a beat, and 16th note is an eighth of a beat. It would change. And the corresponding rests change with them. And as we said with rhythm, rhythm is the duration of pitches, accents, or silences. And those silences are important. We have to count our rests. So we understand how that should work. Now, because we want to have as much flexibility with rhythm as possible, they introduced the dot and the tie. So the dot is a formula. You add half of that note value to itself. That is what the dot means. So the dot is a variable. It does not equal a specific number of beats. It changes dependent on the note that it dots. So, let's go back to our more traditional whole note equals 4 beats, half note 2, quarter note 1, eighth note a half, 16th note a fourth. If I create a dotted half note, so I put a small little dot after the half note, the dot is half of the whole note that you add to it. So a whole note gets 4 beats. Half of 4 is 2. 4 plus 2 is 6. So a dotted whole note, in this case, would be 6 beats long. So the dot, in this case, is equal to 2 beats. If instead we dot a half note, a half note in this circumstance is 2 beats. The dot says half of that, which is 1. 2 plus 1 is 3. So in this case, the dot equaled 1 beat. Let's keep going. A quarter note, 1 beat. Half of that is a half. 1 plus a half is 1 and a half. One of the reasons I'm doing this so slowly and step by step is that I want to make sure that there's a very logical process. That one for yourself, so that there's no holes in your knowledge, in your foundation of information, so that we can build upon that to more and more complexity. Also, this is a really great way to, if you ever are going to be a teacher, and teach it to people who know nothing. You need to go step by step to make sure it's really clear. Here's where it starts to get a little bit more challenging, especially for those of us who did not pay as much attention in our math class as we should have. An eighth note is half of a beat. The dot is half of that, which is a quarter. A half plus a quarter, common denominator at 3/4 of a beat. And then the dotted 16th note, a fourth of a beat, half of that is an eighth. A fourth plus an eighth equals 3/8 of a beat. So that is how the dot works. And it allows to have, again, more variety of rhythm. And the reason this system of rhythmic notation has continued for over 600 years is because it allows so much variety of rhythm. It's really a very good system that they came up with in the 14th century. Now the tie is another way in which we can achieve different rhythms. The tie adds 2 note values together. So I'm going to erase this part. I can take a half note and a quarter note and put this little line here. The line always goes with the note head, closest to the note head. It never connects at the top with the stems. It's always with the note head. So let's say the stems were to be going down. The line would go like that. So it's always closest to the note head. What it does is it adds these 2 note values together. So using our common note value designations, 2 beats plus 1 beat, these would equal 3 beats. Well, that's just another way of that dotted half note. And there's going to be different circumstances where one is preferable to the other. If we're going over a bar line, and we're going to talk about that momentarily, you have to use a tie. Now a tie connects, these pitches have to be the same pitch. So pitch 1, pitch 2. For it to be a tie, they have to be the same pitch. What's confusing is that this designation is also used as a legato marking in music. So if you had, let's say, something that looked like this. Let's say it's treble clef. B, C, D. This one is a legato marking, which means it would be slurred, played smooth and connected, not re-articulated. This is a tie, because it's the same pitch. That means that this is one note. It looks 2 note heads, but it's one sound that lasts 2 beats. So be careful to distinguish between a tie and a legato phrase, what's also called a phrase marking. We can add all sorts of note values. So we could say we have an eighth rest followed by an eighth note tied to a quarter note, bar line tied to a half note. Since these are all the same note, you can chain them with multiple ties so that you would say, this is half of a beat, that's 1 beat, that's 2. So that would be 3.5 beats long. That is how a tie functions. We're going to talk about one other way in which we can modify rhythm and have more variety. That is the triplet. In this entire system that we're talking about here, the number 2 is the most important number. Each one is dividing by 2, being cut in half. However, you can also divide things by 3, and that's where we have triplet. So we'll start with the most common. We take our eighth note, which normally is half of a beat, and instead we say, instead of wanting 2 eighth notes in every beat, we want 3 things. They'd still be called eighth notes, but they're called eighth note triplets because there's going to be 3 of them. So the eighth note triplet versus just the plain eighth note. We don't write a 2 because it's kind of assumed. So this would be 2 eighth notes. This would be 3 eighth note triplets. How do we know that they're eighth note triplets? A black note head, a stem, and one single beam. A single beam. Now, the idea of triplet can be used on all note values. Most commonly on the eighth note. Next most commonly is with the quarter note. So normally we might have 2 quarter notes, which would take up the same space as a half note. We could have something called a quarter note triplet. Notice it's still a quarter note in that it has a black note head and a stem, but I have this bracket with a 3 that goes above it. It's not a beam, it's a bracket that goes above. And that indicates in the same space that 2 quarter notes went, I now want 3 sounds. So, if we go back to keeping track of where our beat is, this is our beat, and I said we're going to have eighth notes, dot, 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 2 of them in every beat. And now I'm going to have eighth note triplets. Now I need 3 sounds in every beat. So instead of going 1, 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, dot, 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 dot. That would be an example of an eighth note triplet. For quarter notes, da, 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 da. Now instead of having 2 of them, 1 with each beat, I need 3 of them within 2 beats. Da 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 1, 2 da da da. So you have that relationship as well. Now we're getting into some more complex rhythmic structures, and how you then relate those, subdivide those, is something that we can talk about at another time. But that gives you all the things we need in terms of how note values and rests work, how they can be modified with the dot, with the tie, and with the triplet function. Now, at this point, we can talk about meter. Meter is a grouping of beats. How you group beats. So the beat is your steady pulse. The note values are measured by beats, but at no point have we talked about the necessity or how meter is determined. So in music today, most commonly, a meter of 4. Very common meter, 4. We would call that quadruple meter. I'm going to erase this part here, write that under here. So a meter of 4 is called quadruple meter. How do you group beats together? Well, you can't pause. A rookie mistake when I ask this question is I say, give me an example of a meter 4, and people go, 1, 2, 3, 4. 1, 2, 3, 4. I go, you're not clapping a beat because you're stopping. The beat has to go steady. And then they'll go 1, 2, 3, 4, 1, 2, 3, 4. I say, that's good, that's better. But if you were not to be counting the numbers for me, how would I know just by the way you're clapping? Because if you just go like this, how do I know that's 4? A group of 4 versus a group of 3 versus a group of 2. How do you make it obvious what the meter is? The answer is you have to accent. And that is what meter is. It's an accent. So if I were to go now it is obvious I'm in a meter of 4 because it's loud, soft, 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 loud, soft, 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 loud. I'm still clapping a beat. What I'm making different is the volume. What that means is in a meter of 4, beat 1 is the most strong, the most accented, the loudest. That's what makes it perceivable as a meter of 4. So it goes 1, and then, so that's the biggest one, right? Loud. Beat 2 is pretty soft. 3 can be like a medium accent. And 4 is soft. So it really goes loud, soft, medium, soft in terms of its metric accent. And that's how we know it's in a meter of 4. With that same logic of we have to have an accent to determine meter. I'm just going here, this is a beat, and now I want a meter of 3. I just need to make the beat 1 of the grouping of 3, because again, meter is how we group beats. It's the grouping of beats, grouped by their accent. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So, a meter of 3 is called triple meter. It would have the accent of loud, soft, soft. 1, 2, 3. Duple meter, which, as you can guess, is a meter of 2, where you have loud, soft, loud, soft. I point this one out so that you can compare and contrast with quadruple meter, because these can be confused if you're not listening carefully, or as a performer, if you're not performing carefully. A meter of 2, a duple meter, should sound different than a quadruple. So if I have 2 measures, duple, it should sound different than 1 measure, quadruple. Let me define this measure for you. A measure is 1 time through the meter. So if we have a meter of 4, 1, 2, 3, 4, 1, 2, 3, 4. That's just the structure. If I go 1, 2, 3, 4 once, that's 1 measure. If I do it again, that's the second measure. So every time I go through the cycle of the meter, quadruple, triple, or duple, that equals 1 measure. 1 measure of quadruple, using our most common, where a whole note is 4 beats, is 4 beats. 2 measures of duple is also 4 beats. What's the difference? Well, it has to do with the metric accent. So each one of these would be 4 beats in length. But 2 measures of duple would go loud, soft, loud, soft. Whereas 1 measure of quadruple would go loud, soft, medium, soft. A subtle difference, right? It's not super huge. You can see why it could be confusing if you weren't performing it or listening carefully, right? But that's the difference. This is 2 measures of duple. This is 1 measure of quadruple meter. That's what's important to keep in mind in terms of the differences of meter. We talked about what the measure is. Now what we can talk about is the difference between simple and compound meters. So, a simple meter means that you have a duple subdivision of the beat. Duple subdivision of the beat. This is going to be pretty normal, what we expect. Compound meter is where we have a triple subdivision of the beat. So, let's kind of see what that's about. We're going to jump forward with time signatures to the time signature idea. The time signature, and here's an example, 2-4, has a top number and a bottom number. The top number in a time signature tells us the number of beats in a measure. It's telling us the meter. So the top number tells us the meter. If we have a 2, it is a duple meter. A 3, triple meter. A 4, quadruple meter. And those are the common ones that we're going to be talking about. So, top number, the number of beats in a measure. That's our meter. The bottom number tells us number of, it's going to tell us what note value is getting the beat. And so there's a couple different ways we can think about this. If it's a simple meter, then this bottom number is the number of beats in a whole note. Okay? So if it's 2-4, that means there's 4 beats in a whole note, which is what is our kind of most commonly used today. This is 4, again, this changes when we go into compound meters. Compound meter gets very different, so just think about simple meter for right now. Sometimes people will say, well, the 4 indicates the quarter note. The quarter note equals 1 beat. So you could say, okay, it doesn't matter what this would be, 1/4, that's a quarter, so with the 4 on the bottom, quarter note equals 1 beat, whole note equals 4 beats. That means if I were to say 2/8, this would be a duple meter where there's whole note gets 8 beats. That means the 8th note equals 1 beat. 2/4. Let's change that up. Let's say 3/4. That's a triple meter, 3 beats per measure. The 4 means whole note equals 4 beats. When we do the math, it means the quarter note equals 1 beat. So 8th note, 8 on the bottom, 8th note equals the beat. 4 on the bottom, quarter note, right? You seeing a relationship? If I were to have a 2 on the bottom, like 4/2, 2 half note equals the beat. So you can see how the bottom number tells you what's getting the beat, what equals 1 beat. The top number is telling you the meter. This is all for simple meters. The reason that works is because a simple meter is the duple, the subdivision of that beat. In a compound meter, we can still have duple, triple, or quadruple meter, but we have that subdivision being 3 things, three notes. So if we were to say, take where we want a duple meter, but we want it to be compound. So a compound duple. Let's say that we want it to be where this is a little bit trickier to explain. You have 2 things going on. You have what is the actual beat and the subdivision of the beat. So let me give you the example and we can extrapolate. 6/8 would be an example of a compound duple meter. Let me explain why. The rules we used here no longer apply. So you would say, Dr. Brellochs, 6 is on the top, there's 6 beats per measure. That's actually not the case anymore. 8 is on the bottom, 8th note equals the beat. No. Here, these are the subdivision in a compound meter. So what that would mean is that there are 6 eighth notes in a measure, but they're not what equals the beat anymore. There's 3 of them that get grouped, and that's what is actually the beat. So the dotted quarter note is the beat. 3 eighth notes go into that. So we have 1, 2, 3, 4, 5, 6. That's where the 6 comes from. These are all eighth notes. That's where this comes from. But that's not how it actually gets felt. It gets felt as 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 4, 5, 6. Sometimes people talk about the big beat, which is this, and the little beat, which is the 1, 2, 3, 4, 5, 6. So usually they're at a tempo where you couldn't tap it would be too fast to tap your foot. 1, 2, 3, 4, 5, 6, 1, 2, 3. You know, your foot would cramp up after a little bit. So we have this compound meter. The compound meters for duple, it's always a 6 on the top. For triple, it's a 9. And for quadruple, it's a 12. So if the top number is a 2, 3, or 4, that's duple, triple, quadruple in a simple meter. If the number is 6, 9, or 12, that's duple, triple, quadruple in a compound meter. What does that mean when we have a compound meter? It means that bottom number is the subdivision of the beat. It means 3 of these equals a beat, right? 3 of these equal 1 beat. So let's say instead of an 8 on the bottom, I had a 4. How would that change things? Well, if I have 6, 4 now as my meter, that means I have 6 quarter notes in the measure. 3 quarter notes equal 1 beat. Well, 3 quarter notes is a dotted half note. That means there's 2 of those. That's why it would be considered duple. That's the actual beat, the dotted half note. You will find that in compound meters, it's always a dotted note value that equals your beat. Always a dotted note value equals a beat. So 6/4, dotted half note, dotted half note, 1, 2, 3, 4, 5, 6, 6 quarter notes. You can do the same thing for 9/8, 9/4, 9/2. You can make that bottom number. Again, the bottom number is going to tell you what equals the beat, what equals the subdivision, and how you figure that out. All right. We will talk about how we can make a chart where we talk about what's the beat, what's the subdivision of the beat, whether it's divided into 2 or 3, and what that note value would be, how we name that time signature, that meter, whether it's 3/4, 6/4, 12/8, 4/4, and then what the numbers that I just said, which would be the actual time signature. So we're going to talk about that, make a chart. That's what we're going to do next. And we're going to take melodies like this one, which is written in 2/4, and figure out how we can write them in different time signatures and what it would look like. So that's how we're going to apply the knowledge that we were talking about right now today. Thank you.